Being one of the most valuable resources, water is the foundation of life, industry, and economy. Despite the fact that 2/3 of the Earth's surface is covered by water, only 2.5% thereof is fresh water. According to UN projections, 25% of the population will have a shortage of fresh water by 2025. One of the key tools for solving this problem is the industrial desalination. Due to the high demand for energy, the desalination systems are often built together with the power stations. Rosatom offers its partners design and construction of desalination complex with the capacity up to 170,000 cubic meters daily, integrated with thermal or nuclear power plants of high capacity. The basic element of this project is represented by the most effective desalination technologies, thermal and membrane, which together ensure high reliability and moderate operating costs with high quality of the final product. The technological process of the drinking water production includes several stages. First, a source water is pre-treated. This process starts with the filter, retaining large particles and suspended solids. Then, sodium hypochlorite and ferric chloride are added for disinfection and coagulation, respectively. Coagulant couples the remaining sand and other small particles into more massive flakes, which then settle down on filtration load. The second purification step may optionally include sand filters or ultrafiltration units. After that, the seawater becomes cleared of sediment and particulate matter and ready for desalination. The integrated system allows to carry out desalination using both membrane and thermal methods. In the first case, the cylindrical membrane elements are used. They contain layers of plastic sheets with pores of diameter 1,000 times less than a human hair, capable to filter microscopic salt ions. Membranes inside cylindrical tubes allow the seawater to flow under high pressure and thus get cleared from the salt. The system comprises several thousand membranes. In case of thermal or distillation method, multi-effect distillation, purified water is instantly heated in special columns and after being repeatedly evaporated, condenses as fresh water. Whereas the vapor formed in the first column heats the other columns, providing a high level of energy efficiency. After desalting process, the water is sent to the mineralization system in order to restore the contents of essential minerals. Now it has no difference from the usual fresh water taken from a natural source and then treated. A desalination complex, integrated with one block of high-power nuclear plant, is capable of providing potable water to a city with 1 million inhabitants. In case of integrated solution, it allows us to jointly infrastructure use as synergetic effect. It resulted in optimization of capital and operation expenses, decreased desalination water cost, and provide an increase of economic characteristics of nuclear power plant operation.